Okay, good morning, everyone. I'd like to say thank you to the organisers and Nindy for having me and letting me talk. So I work for a company called Commerce Block, and at Commerce Block we make and we sell blockchains and blockchain-related services. So yeah, I mean, there's probably not many more less dignified job descriptions in crypto than blockchain salesman. Maybe patent writer at Enchain, but so it's an improvement. So okay, so today, I'm going to talk about blockchains, why they're really great, tokens, why they're really great, especially if they're on a blockchain, and basically, more specifically, I'm going to talk really about our approach to tokenizing of real-world assets and how we believe that it gives the right mix of control, of immutability, and of scalability. So, we've really, I call this talk in defense of blockchains because it's become a bit of a dirty word. We're at the tail end of an insane hype cycle, and it was flogged to death. The buzzword, blockchains, tokens, and we started to hate this word. So I wanted to try and define what we mean by these things, maybe, try and reclaim these words and what they really mean. So, tokens. What do we mean by a token? So a token, when we get down to it, represents ownership of something. Ownership of, could be Bitcoin, an altcoin, or it could be some real-world asset that has value. So, maybe gold, precious metal, other commodities, real estate, or equity in a business. So a token represents ownership of these things, and I think the implication is that it's, when we use the word token, that it's easy to transfer this ownership, and that this can be done, efficiently with little cost. So the way things are traditionally tokenized is we just record the ownership on a spreadsheet, or a piece of paper, or a database, and we list who owns what percentage of what asset. So, the big criticism people have is why use a blockchain for this? Surely these things are centralized anyway. Someone has control of the gold, someone has a key to the vault, someone has a key to the real estate. What's the point of a blockchain in this case? You say blockchain in this case is really just a slow, inefficient database. So this leads me on to my first kind of statement about blockchains. Blockchain is not a database. A blockchain, I really like this concept here. A blockchain is only a proof. You use a blockchain to determine the state of your database. You use the blockchain to independently verify what the contents of your database are. So in the case of Bitcoin, the database is like the UTXO set, which defines the ownership of every single coin. But this can also be, define the ownership of other things. So as well as it not being a database, it's only a proof, a blockchain also has rules when they're verified. So this leads me on to my second statement that I'll make, that again is maybe slightly controversial, but a blockchain is not Git. Git is not a blockchain. A blockchain is not simply just a commitment tree with lots of different things committed to it, like you have in a Git. It has rules. It has rules that define what is a valid transaction and what is not a valid transaction. Maybe transactions require authentication, require digital signatures. Also, a transaction has to follow certain rules in, say, conservation of amounts. Let's say the inputs and the outputs of the transaction have to be equal. But there's lots more rules that a blockchain has to follow. So that goes me on to my third statement that I'll make, in that a blockchain is a lot more than just a distributed timestamping server. So a blockchain is not timestamp. A blockchain is not a time chain. When you verify a blockchain, you verify uniqueness of each individual amount, each individual output. And this is really one of the key properties of a blockchain that isn't often, I think, explained very well, and that it's proof of uniqueness. So there's this saying, you can't prove a negative, but with a blockchain, actually you can. That's the whole point. You verify that only one output can be spent by a transaction. And this was explained by Satoshi in the white paper. The only way to confirm the absence of a transaction is to be aware of all transactions. This is, I think, one of the most important properties of a blockchain, but it's also why it scales so badly. So everybody has to verify the uniqueness of every single transaction. So I came across this article a while back, which was brought my attention to these guys, a guy called Stuart Harbour and Scott Stornetta, who came up with this scheme in 1995, I think, where they basically created this timestamping service where you could submit a commitment to them, and they would include it in a commitment tree or a hash chain, and then every few days they'd publish the root of that in the New York Times, and so you could then prove that something happened back in time. In fact, this was the original inspiration, I think, for Satoshi's blockchain, and he cited Harbour and Stornetta was three of the, I think, 9 citations in the original Satoshi white paper with these guys. But it's not blockchain. This is a time chain, but it's not a blockchain. So this headline is wrong, I believe. So the point I think I'm trying to say is that a blockchain, along with a private key that controls an output, can be an independent proof of your ownership of something, of an asset, with a very important assumption, which I'll go on to in the next slide. So this is very useful because this proof of ownership can be transferred from one person to another person just with a single cryptographic operation with a digital signature. So obviously one important criticism here is you say, well, aren't these assets we're talking about centralized anyway? Someone has a key to the vault, someone has, a key to the property. So how is that proof valuable? But it is valuable because we live in the real world. And if you have your own proof of ownership that you hold independently, you can sue the custodian if they refuse to give you back your asset. They may not even do something maliciously. They just might not be very good at maintaining their own database. So if you have independent proof, this is a really valuable thing. Also, the issuer can't double spend you. The issuer can't defraud you by, telling 2 people that they own the same thing. So a kind of interesting example I read about recently was this issue with Dole Food. They had some issue with the shareholders and the management team, and there were kind of legal troubles. And as part of discovery, they actually found out that there were about 30% more shares than people thought there were. So people thought they owned a certain percentage of the company, but actually they owned a lot less because they issued too many shares. So this is why this kind of independent proof of ownership can be very useful, and that it enables this transfer of ownership to happen very efficiently. So none of this matters if we can't prove that the blockchain itself is unique. We're back to square one if the issuer can create an alternative history of transactions. So the only way to solve this without trusting a single entity, which is the aim, is the solution that Satoshi came up with Bitcoin, proof of work, that gives us a globally objective state, that the longest or the most worked chain is the state that everyone comes to consensus on. It's proof of a single history. This is really a game changer. I mean, I believe it completely redefined what we mean by immutability. And this adds a huge amount of value to any proof of ownership, because now we can have a proof of ownership that isn't dependent on any single trusted entity. So this only gives us kind of probabilistic settlement finality, but in practice this is very quick due to the kind of enormity of Bitcoin's proof of work. So I mean, it's about I think about $1 million worth of electricity per hour goes into making Bitcoin immutable. So ideally then, what we would like to do is we'd like to use Bitcoin to record the ownership of real-world assets. So the way this works is that you can verify the global state of Bitcoin by verifying the Bitcoin blockchain consensus rules. And then you also additionally verify some additional set of rules that prove the uniqueness of ownership of some asset, which will be encoded in metadata in Bitcoin transactions. So this basic model is followed by quite a lot of platforms. Probably the most well-known is the Omni layer, which has probably the highest value tokenized asset ever, like Tether's multi-billion dollars worth of tokenized US dollars. And so this has been really quite a successful method. But there's a big problem, it doesn't really scale. Every single omni-layer transaction has to be a Bitcoin transaction, which is a big problem because Bitcoin's blockchain is very restricted. The block size is capped, which is very, very important because that restriction enables Bitcoin to be easily verifiable, which is a key part of its value proposition, it's a key part of censorship resistance. So this is a problem. We can't scale to a large number of transactions. We can't tokenize a large number of assets. Or we have to pay extremely large transaction fees. So you think, okay, can we do this a different way? And a lot of people do want to do it a different way. Why not use another public blockchain that has more space, maybe where the transaction fees are lower? And this is the model of basically Ethereum with all the ERC20, ERC, whatever tokens. So there's two reasons why this is not optimal at all. So it's not as secure as Bitcoin, it's not as immutable as Bitcoin, and it's much more difficult to verify, to independently verify that proof of ownership. So, I mean, to kind of illustrate why this really is not going to scale, I mean, if you want to, say, verify your ownership of, say, Paxos gold token, for example, if you want to independently verify that and send it to someone, and they have to independently verify their ownership, you both have to verify the full history and supply of every single ERC20 token ever issued. You have to independently verify every single computation of the world computer has ever made. And so you don't care about most of these tokens. You only care about the one token that determines your ownership of an asset. So this is basically our model. So we believe that you should only have to verify the full history of the asset type that you're interested in. So you verify the blockchain that your asset is tokenized on and the Bitcoin blockchain to prove a unique history and a unique state. So in this model, you have a single asset or a single issuer blockchain, which is completely controlled by the issuer themselves. But the uniqueness, the proof of a single history, is derived from Bitcoin and Bitcoin's global immutable state. So this asset-backed blockchain, this secondary blockchain, is completely centralized. Things become a lot simpler when you don't have to pretend to be decentralized. You can add all kinds of custom policy, whitelisting. You can control the transaction fees and charge the transaction fees in whatever asset you want. So this is completely permissioned, centralized. It's not censorship resistant because the chain is controlled by the issuer, but often most asset issuers want that. They want to be able to enforce KYC, whitelisting, to control who can transact. But once a transaction is confirmed, it's trustless. You can independently verify that your ownership is unique. So how do we then go about doing this kind of proof of immutability? So can we just timestamp using Bitcoin? So to illustrate why this won't work, here's a kind of just simple kind of cartoon of us taking some piece of data and committing it into a Bitcoin block. Once we do this, we can then go back and prove that that data existed at the time this block was mined, which is great, and that's got thousands of use cases. However, I could also timestamp alternative data, which actually might conflict with another commitment, and then I can go and selectively reveal or prove one of these commitments later on. And so if we imagine we do this with a secondary asset-backed blockchain, we commit the... Okay. Yeah, of course. So I can timestamp anything into the Bitcoin blockchain. I could timestamp 3 documents and then send the proof of one document into you. You don't know about the existence of the other 2 documents. So if we think about this, doing this with a secondary asset-backed blockchain, we can commit the state into Bitcoin. Say every now and again we do a timestamp into Bitcoin. But I could, as a corrupt issuer who wants to basically double spend an asset, I can do this with a separate version of the blockchain, a separate history, and also timestamp that in. And I can give one version of history to one set of token holders, another version of history to another set of token holders, and double spend the asset. So the solution to this is to exploit the provable uniqueness of Bitcoin transaction IDs. So this is basically first explained by Peter Todd using what he called a single-use seal, so that you basically use a Bitcoin UTXO as a globally unique identifier, and you start your single asset sidechain and you bind it directly to a single transaction ID. And so in that way, if you then commit the state of your blockchain into transactions that come away from that UTXO, and you enforce a new rule that every transaction that comes out of that unique transaction ID can only have a single output. And that's the additional rule that you now verify that can prove the uniqueness of this second blockchain. So I'll quickly kind of explain how this works. It's very simple. We called it mainstay. And essentially what you do is you have a transaction ID on Bitcoin where the asset, in the simplest model, the asset issuer controls the private keys for this output. And then you commit that transaction ID into the genesis block of your single asset blockchain. And then you sign blocks on the single asset blockchain, and then periodically you then commit the state of the single asset blockchain back into the Bitcoin blockchain into a transaction that spends directly from this initial output. And then you can repeat this, and now you can verify that there's only one single possible history of your single asset blockchain against Bitcoin's proof of work. So how do you verify this? You have to run a full Bitcoin node. You have to run your single asset chain node, and also this mainstay daemon, which then verifies these commitments and verifies the proof of a single history. And then you can get a confirmation in your wallet. So this requires key custody to run, so it's centralized. But verification is trustless. So once the commitment's gone in, you can then independently verify it without trusting anyone. one of the advantages of using this method, as opposed to just relying on a digital signature in Bitcoin, is that it's compatible with SPV verification. And so we can, obviously SPV verification is not as secure as running a full Bitcoin node, but it still adds value, and users can still, in lightweight user wallets, can do full verification of the asset-backed chain, and then SPV verification of Bitcoin. And so in the user's experience, they actually get 2 levels of confirmation. So they get an initial confirmation when the asset issuer has added blocks to the blockchain, and then they get a secondary confirmation that this has been now backed up into Bitcoin. And here, this lightweight wallet connects to the Electrum network and Electrum servers to get those proofs. So this is the basic idea, but also this doesn't really scale. So, if we were going to have every single asset using this mechanism to take Bitcoin's immutability, this also didn't scale because, if we have every single asset making commitments and running Bitcoin transactions, there's still not enough space in the Bitcoin blockchain. This is what, well, yeah, there's Veriblock doing its thing. So we created another extension of this, which allows us to run this as a service. So we call this the mainstay connector, and so this uses basically compresses commitments down in a Merkle tree, just like Open Timestamps does. But the main difference being that the position in the Merkle tree is basically kept the same between commitments. And so users have to basically reserve what we call slots, so slots are basically positions in the commitment Merkle tree going into Bitcoin. And so long as the commitments always stay in the same slot, you also commit the slot ID to the genesis block of your single asset blockchain, then you still get the same property of immutability and having only a single history. So we run this as a service, and basically, obviously, we then control the keys, which are propagating what we call the stay chain, which is this chain of one output transactions in Bitcoin. We kind of taken quite a lot of care over the security of this, because although it's, like I said, it's trustless verification, in order for us to keep the service running, we need to keep these keys very secure. So we use multi-sig, we use hardware security modules. We also do pay to contract for the commitments, so we don't use op return on Bitcoin, which saves a bit of space, saves a bit of money. Also, we're never going to get blocked by the miners for having op returns in our transactions. So basically, yep, that's it. That's the story of Mainstay and our model for tokenizing assets. It's only one of what I've talked about today is one of the few things we've got in a few projects. So we've got Chain Cert, which is actually SSL certificates for individual asset-backed tokens, so that you know the details of the actual chain you're using to receive tokens. Data Cert, which is a service we're developing for doing kind of document management using this Mainstay protocol. Ocean Platform, which is our blockchain client, which is derived from Elements. And Guard Nodes, which is a project we're about to launch, which is used to incentivize people to run nodes. So that's it. Thank you.
Questions, anyone?
Can you speak a little bit about the recent Liechtenstein law and how that affects, because you were talking about tokenization of assets?
Yeah. So which law, sorry?
Liechtenstein, they recently passed a law that actually provides legal backing for tokenized assets, saying that you could actually bring your token to a court of law there and say, yes, this token does represent legally represents this piece of,
Yeah.
yeah.
Well,
So-
ideally, that's what we would hope that all jurisdictions recognize. I mean, this is all very experimental stuff. I mean, I'm sure if you went to a court now, it would probably be painful to convince the judge of your ownership based on a cryptographic proof or a cryptographic token. But this is the world we want, yeah. We want to be able to, this to be recognized, and this will hopefully, which is the main aim is just to make it easier for people to trade things and easier for people to transact. So, cool. Cool. Okay. Cheers. Yeah, thanks.
Thank you.
Oh,
Thank you again.
sorry.